Here in this video, we want to find out dimensions of resistance in terms of regular values like electric current, mass, length and time. And it's a very basic question where we need to know from where this resistance comes itself. So if you remember, basing on the Ohm's law, voltage can be written like I into R. Oh, so I need to know the dimensions of resistance. For that, I shall know first of all the dimensions of voltage and current. So if you remember the definition of potential or voltage defined as work done in bringing a unit positive charge from infinite distance up to a point. So if you write dimensional formula, work could be anything like Fs by charge could be written like It because current is defined as rate of flow of charge. Fs could be written like MAS by It. Now you write the dimensions of each of these things. Mass as a dimension of capital M. Acceleration is rate of change of velocity. Velocity is Lt power minus 1 by time, then it becomes Lt power minus 2. Displacement is L. Current is represented with I. So ml square T power minus 2 is the energy work done dimensional formula. Charge dimensional formula is It. So together potential has a dimension of m L square T power minus 3 I power minus 1. For potential we have found. Now I also have to write for, as I already written, for current. Current is defined as rate of flow of charge. Q could be written like, of course, It. So current has, being a fundamental quantity, has a dimension of I itself. Now I need to find out for resistance. So resistance can be written as V by I. V has a dimension we have already found, ml square T power minus 3 by power minus 1 by I is, by I is there, that's I itself. So dimensional formula of resistance is m L square T power minus 3 I power minus 2. So where do you have that kind of an option? ml square T power minus 3 I power minus 2 is option D. That's the answer for that question, right? So while you are solving this question, the method that we have followed is quite simple. What we have done is we have written the formula where you get the resistance. There may be many other ways to find these resistances, but this is the simplest way that I have. I have written dimensional formulas for each of the physical quantities that are available, and I have just substituted so that I got the value of the dimensional formula of the resistance. This shall be the approach in solving any of the units and dimensions problem. We shall go for the core concept, write dimensional formulas for each of the physical quantity, substitute so that you will get a final dimensional formula too also. So this is simple, but you shall have a knowledge of the overall physics chapters that you have studied across first year and second year to answer this kind of questions, right? So you shall not by heart them, rather you shall always derive basing on the concepts that are available in our lessons. That's it. Thank you for watching.